So welcome back. We are going to look at question number 9 on our list of questions for the midterm exam of Math 304 section 1, 2 and that of 3. So let's quickly get into the video. Find a differential equation whose solution is given by the differential coefficient of y equals the ln of tangent of x. Find that differential equation. Now, to find that differential equation, we need to differentiate this expression. So, following our normal rules, we write y is equals to the ln of tangent of x. So, differentiate y, the derivative of y is y prime is equals to the derivative of the ln of anything. So, the ln of tangent x is 1 over tangent x times the derivative of tangent x. So we should just say our note, we should just put a note right here, note the derivative with respect to x of the ln of any function is equals to 1 over that function times the derivative of that function. Simple as it is. So for those of you who have done your calculus 2, you know what we're talking about. And for the fact that you are doing this course or you are watching this video, if it is not coincidental, it means that you have some prior knowledge on what we are discussing. So great. So move on and write y prime is equals to 1 over tangent x times what is the derivative of tangent of x? We know very well that secant square x, right? Secant square x. Good. Now, you know, and I know that when we have these things, we can express in terms of sine and cosine. So I can just put a quick note right up here, and I can do that in red marker. So I'm going to say note, if you have tangent x, that result is sine x over cosine x. And secant square x is 1 over cosine square. So secant square x is 1 over cos square x. These are the two identities I want you to know. So let's just go right ahead and just put them, plug them in. So we have y is equal to 1 over this tangent x is sine of x over cos of x times secant square is 1 over cos square x. Simple as it is. So we move from there, and then once we get that, we move on to write something like this. We move on to write something like this. So y prime, I'm just going to rewrite that, is equal to 1 over sine x over cos x times 1 over, now this cos square x is cos x times cos x. So cos x times cos x is cos square x. So because this is like in the numerator and this in the denominator, this and this are going to cancel out. So one of the cos will cancel out, and then you just have y prime is equal to 1 over sine x times cos x is sine x cos x. But we know that there is an identity that resembles sine x cos x, and that's sine 2x. Sine 2x is equal to 2 sine x cos x. So we have to write it as 2. So we say 2 over 2 multiplied by 1 over sine x cos x. As I'm bringing this 2 is to bring in the identity for sine 2x. Great. Once we do that, we can take this 2 inside here a little bit. So we have y prime is equal to 2 parentheses opening 1 over. Bring this 2 in here, we have 2 sine x cos x. And then we have 2 parentheses opening 1 over 2 sine x cos x is sine 2x. That's what we have. 2 sine x cos x is sine 2x. Great. Once we have that, we can proceed to write y prime is equal to 1 over sine 2x is cosecant 2x. So y prime equal 2 cosecant 2x, or dy by dx, because y prime in this case is dy by dx, is equals to 2 cosecant 2x is a solution to that differential equation. Thank you very much for watching, and see you in our next video.